Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about introduction to set theory. So many of the people know that at the 10th and intermediate level itself. So set is nothing but a well-defined collection of objects called elements and members of the set. A specified set can be defined in two ways. So if there are only the few elements, they can be listed individually by writing them between curly braces and placing commas in between them. And the second way of writing the set is to use a property that defines the elements of the set. So example, I can able to define x such that x is an odd and 0 less than x less than 100. If x is an element of the set, then it can be written as x belongs to A. If x is not an element of A, then I can able to write this as x does not belongs to A. So set is nothing but a well-defined collection of objects called elements or members, not the set. Normally, a set can be specified in two ways. So if there are only few elements are available, so they can be individually listed, and by writing them in curly brackets and placing the commas in between them. Suppose if I'm going to write a prime number set, so I can able to write 1, 3, 5, 7, 9 like this. So these elements, what can able to call as elements or members of the set. This is the one way of writing. And second one is that you can also use a property that defines the elements of the set such that. So second way of writing the set is that x such that x is prime and in between the values x 0 less than x less than 10. So this is the another way of writing the set. So most probably you are going to be prefer this kind of notation only. And suppose if an element x on the set A, how can I able to write? So I can able to define x belongs to A. So x belongs to A. Similarly, if x is not an element of the set A, then I can able to write it as x does not belongs to A. So like this, we are going to be writing the notations in the set. Suppose here 5, so 5 belongs to P and 10 does not belongs to P. So here the 5 is the element of the set and 10 is not the element of the set. So that's why it does not belongs to P. So like this, we can able to define the set. So the set can be defined and collection of objects called elements and members and can be specified in two ways. So first one is that set of members and member functions, and x is an element of set A, then you can able to write it as x belongs to A, and if x does not belongs to set A, then I can able to write it as x does not belongs to. Then what are the different types of sets or special sets we are going to have? So some of the standard notation that can be defined here is that n is the set of all natural numbers. So 0, 1, 2, 5, 6, 7, 8, and 9. Not only 9, so all the set of all the natural numbers is the one of the set. And Z will set of all integers, and Q is the set of all rational numbers, and set of all real numbers, and the C is the set of complex numbers. So like this, we are going to have some of the special sets, what we call as the universal sets, and we are going to have some of those standard notations as well. So natural sets, integers, rational numbers, real numbers, and complex numbers. So these are the different types of sets we are going to have. So under types of sets, so what is first thing is that subset. So if every element of A is also element of B, then we can able to say that A is the subset of B. Suppose I'm going to have, so how can I able to represent it? A subset of B. That means every element of A should also be present on B, then I can able to write A subset of B. So if I'm going to have the set 1, 2, 3, and B is equal to 1, 2, 3, if it is, then I can be able to write A equal to B. That means both sets are equal, right? Suppose if I'm going to write the elements of the set is 1, 2, 3, 4, 5, 6. So the elements of A is also present in elements of B. So at that time I can able to write as A should be subset of B. That means the elements of A is also present in elements of B. So see the example here 1, 2, 3, 4, 5, 6, and B is equal to 1, 2, 3, 4. So I can able to write B is subset of A. That means 1, 2, 3, 4. The entire elements of B is also present on A. So that's why I can able to write it as B sub. Like this, we are going to define the subset. And next one is equal sets. Equal set is nothing but the two sets are going to be equal if I'm going to have equal numbers and similar type of elements. So A is subset of B and B is subset of A. That implies A equal to B. See the example here. So I'm going to have A is equal to 1, 2, 3, 4, 5, 6 and B equal to 4, 1, 5, 6, 3. So then the elements of 1, 3, 4, 5, 6 is also present in here. So at that time I can able to write A is subset of B and B is also subset of A, and both can able to write it as A equal to B. So that should be equal sets. So the both sets are equal if I'm going to have equal numbers and similar type of numbers. So I can able to say the both sets are equal in the same by considering this length of the set also. So based on the length of the set, so what is the length of the set? For this one is 5 and B is also 5. So at that time also I can able to say that the both sets are equal. And based on the numbers and elements, I can also decide so whether A equal to B or not. And next one is the MC set. So set does not contain any elements called as MC set or null set or void set, and that should be denoted by pi or I can write null set. The set which contain only elements is called empty set or null or void set denoted by pi or null. The set of whole numbers less than 0, and clearly there is no whole number less than 0, so therefore it is an empty set. And I can able to write so x such that x belongs to n, that should be based on the condition 3 less than x less than 4. So null set is the set which does not contain any elements. So I'm taking an element set here. So it does not contain any kind of element, then it should be called as an empty set. Or null set I can able to write, or I will write the void set, and it should be denoted by that means this is the null set which does not contain any elements, or simply I can able to write simple form brackets. Suppose so the set of whole numbers less than 0. So whether any elements are there available? No. So again you will write fine. Clearly there is no element less than 0. That's why it is an empty set. So based on the condition, so n is the set. So here x such that x belongs to natural numbers. Okay, and the x should be lies in between 3 and 4. So nothing is available. Then it should be fine. So let's take another example. So x is equal to 2 less than x less than 3, where x is the natural number. So no other element is present in between 2 and 3. So here A is an empty set because there is no natural number between 2 and 3. And B is a composite number less than 4. So these are some of the examples of empty sets. And next one is singleton set. What is singleton set? So singleton set is the set containing exactly one element, and let B be then x is a prime number. So B is a singleton set because the only number which is even, so that is 2. And x such that x is either prime or composite. So it is also a singleton set containing only one element of A1. So singleton set is the set containing only one element. So null set means it does not contain any element. Singleton set is the set containing only one element. So null set is the set containing does not contain any element, and singleton set is the set containing only one element. So here X should be neither prime nor composite, and it is a singleton set containing element 1. The next one is finite set, a set which contains a definite number of elements is called finite set. An empty set is also a finite set. A set which contains a definite finite number of elements. So that should be the finite set. An empty set is also a finite set. So example, set of all colors in rainbow, that should be finite. And then x such that x belongs to n, then x should be 7, true. And x is equal to set of prime numbers, so which should be also a set of finite set. So here the finite sets means only the fixed one, does not change any elements of the set. So rainbow, so if I'm going to consider rainbow, so what will happen? There should be only some 7 fixed colors. So it should be a finite set. So based on the condition, so x is equal to x such that x belongs to n, x should be less than 7. So automatically it should be only 1, 2, 3, 4, 5, 6. And next one is p 2, 3, 5, 7, 11, 13, 17, 97. So x, so 2, 3, 5, 7, 11 should be the finite set of prime numbers from 0 to 100. An infinite set means this is the set whose elements cannot be listed. So that is a set containing never-ending elements called infinite set. So for example, set of all points in a plane. So such x such that x belongs to natural number, then it should be greater than 1. So that means, so 2 is greater than 1, 3 is greater than 1, 4 is greater than 1, 5 is greater than 1, 6 is greater than 1, like this. So these are no will be the set of numbers which is going to have infinite set. And set of all prime numbers. So x is equal to 2n. So infinite set cannot be represented in roster form, that is the note you have to be remembered. So infinite set is the set whose elements cannot be listed and containing never-ending elements. And for all set of points in a plane, so x is equal to x such that x should be less than 1. And set of all positive numbers x such that x is equal to 2n. Our next one is that cardinal number of a set. So what is cardinal number of the set? So the number of distinct elements in a given set is called cardinal number of the set and is denoted by n of a. So cardinality should be denoted by n of a. For example, x such that x belongs to n and x should be less than 5. So what are the elements of the set? 1, 2, 3, 4. That should be the cardinal of the set is 4. And set of letters in the word algebra. So A R G E P R. So the cardinality of the set is 6. So the number of elements that are present in the set should be treated as cardinality of this set. The next one is disjoint sets. So the two sets are said to be disjoint if they do not have any element in common. So x such that x is a prime number, b subject b x such that x should be a composite number. So clearly both are not equal, and by some other cases it should be equal one. So what I'm going to say, I have to specify is equal to 1, 2, 3, 4. B is equal to A, B, C, D. So both sets are equal, so both sets are called as disjoint set. So by considering example like x is a prime number and x is a composite number, so one element should be considered and should be treated as a disjoint set. And next one is that power set. So the collection of all elements of set A should be the power set of A, that is denoted by P of A. And in P of A, every element is a set. So power set is something different from other sets. So here the collection of all subsets of A called power set of A. And is denoted by P of A. So in P of A, every element is a set. So for example, if A equal to PQ, then all the subset of A should be this one. A number of elements of the set should be. So in general, if I'm going to write so P of A is equal to, then I can able to say that M should be a number of elements in set A. So PQ is going to define the all subsets A, I, Q, Q, PQ. A number of elements of set A is 42. Then in general, so P of A is equal to 22 and should be the number of elements in the set. And next one is universal set. A set containing all the elements of the given set is called universal set. And the symbol for denoting the universal set is U. And I can able to write like this. And for example, if A set A is equal to 1, 2, 3, B is equal to this, and C equal to this. So the union of all the sets should be common elements should be repeated, and then this. So A should be the subset of union, and these are the subset of union. I can able to say that B should be the subset of union, and U should be the subset of A, and A should be subset of B, and U should be subset of C. If P is a set of whole numbers and Q is a set of negative numbers, then the universal set should be the set of all integers. And V equal to this one, B equal to DE, and C equal to FGHI. So the universal set should be the combination of all the elements which are common in all the sets, and that should be treated as a universal set. And next one is operations on sets. So here we're going to perform two kinds of operations: union of sets, intersection of sets, and then complement of the set and Cartesian product of sets. So union of sets means, so if I'm going to have 1, 2, 3, B equal to 1, 2, 3, 4, 5, 6. So union. So union I can able to write. So union and B is equal to 1, 2, 3, 4, 5, 6. And intersection means there should be common in two sets. So 1, 2, 3. So this should be the intersection B. So the common elements that are present in two sets, that should be the intersection of two sets. And complement of set, so A dash is equal to mu minus C. So mu is a universal set and A should be the set of elements. You can able to write. And Cartesian product of two sets, so you can able to multiply the two sets. So A into B equal to B into A. Let's see the example. So union of the set. So union of two sets would be the smallest set containing all the elements of both the sets. So A and B is equal to X such that X belongs to A or X belongs to B. So in this A union B, so all the elements are going to present in set A only. So intersection of the set means, so A and B are the two sets of intersection and we should be denoted by A intersection B, and X such that X belongs to A and X does not belongs to B. So if A intersection B is equal to pi, then I can make the sets of set to be disjoint. So these are the two sets, right? So A and B. So the common of both the sets should be treated as intersection of the set. And complement of the sets looks like this. Here we can able to define mu. So mu is the inverse set and A is the complement set. So I'm going to delete the elements of A2C, then it should be treated as a complement of the set. And subsets, so A is a subset of B and only if the element is the element of B. And notation should be treated as A is a subset of B and A should be subset of A. And then A is the proper set of pi. So if pi belongs to B and A belongs to B. So union of sets, so on set builder form what we call it as. So X says that X belongs to A or X belongs to B. And next one is the intersection of sets. So intersection of A and B should be denoted as A intersection B. So X says that X belongs to A and X belongs to B. And A is the set of even positive numbers and B is the set of positive prime numbers. So how can we write? So A intersection B, that should be treated as 2. And definition is that so A and B are disjoint if and only if A intersection B is equal to 1. And next one is complement. So A is a subset of universal set, then complement of A should be that. So A complement is equal to X such that X belongs to mu and X does not belongs to A. And A intersection A complement is equal to pi and A complement is equal to mu. And next one is set builder from Venn diagrams. So set A is going to be presented as a disk inside a rectangular region presenting mu. And the two possible diagrams of two sets should be Venn diagrams. So union, intersection, and then union, intersection, and then A and B union. So the complement of the set A should be written as A and A complement. So this should be the set A. It should not be appear in complement. So union of two sets should be written as like this. An intersection of two sets. So the common part of two diagrams. And then the sets formed by the sets. So this should be the region of A intersection B complement. And region 2 should be written as A intersection B. And region 3 should be written as A intersection B complement. And R4 should be A intersection equal to A intersection. So what are the two basic counting principles we have to follow? So n of A and B is equal to n of A plus n of B minus n of A intersection B. So from this also I can able to apply. So n of A intersection B is equal to n of A, n of B, n of C. P. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.